Already we have solved this type of numericals. If you check the previous videos, you will come to know. But there the opening or the bucket was on the horizontal ground or along the x-axis. Here the opening is along the y-axis. Let's see how to solve this one. The question is, a ball is getting rebound at 70 degree, so it is shown here from point A. This is point A as shown in the below figure. Determine the range of velocities. So whenever it is range, it will have two readings for which the water, see, it should be for which the water will enter. It should be water for which the water will enter the opening CD in the vertical wall. So now if we look into this one, to enter this water jet through point C, uh, through point C, it has to travel a distance of 1 meter along y-axis. Now to enter this water jet through point D, it has to travel a distance of around 1.5 meter. So it has to travel two distances along y-axis. One is 1 meter, so I am calling this as y1. So y1 is equal to 1 meter and y2 is equal to, it is 1 plus 0.5, it is 1.5 meter. Again there are two cases. So that is case 1. In the case 1, v0 is the question mark and alpha is 70 degree. X is what here? See, x is this one. It is x 0.75 meter and y1 is 1 meter. For the case 2, v0 is the question mark, alpha is 70 degree, x is 0.75 meter, y2 is 1.5 meter. So these are the two cases, and if you look into this one, if you look into the given data, the relation between x and y is known in the case 1 as well as in the case 2. That means we have to use the equation of a projectile, that is equation of trajectory. So let's use those. I am copying this data for the case 1. So that is, so this is the available data, and the equation of trajectory is y is equal to x tan alpha minus gx square upon 2u square 1 plus tan square alpha. So substituting all these equations values in this one, it is 1 is equal to x is 0.75 tan 70, it is minus 9.81.75 square upon 2. U is v naught square here, u is v naught square, multiply with 1 plus tan square 70. So on solving, it becomes 1 is equal to 2.060 minus 23.586 u square. Sorry, it is v naught square. V naught square, and on solving this one, we get v naught as 4.717 meter per second. So if we wish to enter this water jet through point C, the velocity should be 4.717. Then let's find the another velocity for which the water is going to enter the opening CD. So I am copying the case 2 data. So this is the case 2 data. Again, the relation between this x and y is known. So using the equation of trajectory, x tan alpha minus gx square upon 2u square 1 plus tan square alpha. So substitute the value in this one, that is 1.5 is equal to 0.75 tan 70 minus 9.81 0.75 square upon 2 v naught square 1 plus tan square 70 it is. On simplification it becomes 1.5 is equal to 2.060 minus 23.586 upon v naught square, and on solving this one we get the value of v naught as 6.486 meter per second. So I can write a comment here, that is the velocity should be between 4.7172 to 6.486 meter per second, and this is the solution.